For Abby, we'll erase the I so she just sees the Z. So she knows it's that one, not to get confused. Number families with the symbols, and then we're on rationals. Decimals that terminate or repeat, these are terminating ones. What about repeating decimals? Can you write them as a fraction? Do you remember how to do that? Put it over 9. 5 over 9 is 0.5 repeated. That's why it's a rational number. What about 0.13 repeated? 13 over 99. Hmm? 0.133333? So then that would be, so 0.1 and just the 3 repeated. Okay? This, if I multiply this by 10, I get 1.3 repeated, which would be 1 3/9 or 1 1/3. Okay? Now, if I would take that, which is the same as 9, well, let's just make this 1 1/3. You agree that that's the same as 4/3? What would I have to do to move the decimal place over once this way? I'd have to divide by 10. So if I did 4 over 30 by dividing by 10, I would get decimal 13333. So if you find out when it's repeating, you could just multiply by that amount to move the decimal over, then divide afterwards. It's a good question. I like that. So all of these families are connected because if something's a natural number, it's also an integer, it's also a whole number, and it also can be written as a fraction because every one of these ones that we had before, you could put over 1 and you could write them as fractions. Then there's irrationals, which are not connected to the other ones at all. The symbol for irrationals is a Q with a line over top of that. Means not Q. It doesn't mean Q repeated forever. Or sometimes you'll see it with a little squiggle in front. Does anybody know what that squiggle is called? What's the name of it? No, it's just got one squiggle. I'll use the one with the bar over top. It's a tilde. No? I don't know why it's called that. So decimals that do not repeat or terminate, many square roots, but not all square roots, and special numbers like pi and e. Have you heard of the number e before? No, that's different. There is an e button on your calculator. It's right below the pi button. If you take out your calculator, you can go second e, and there it is, 2.7. And put them all together, and the symbol that you'll use the most from now until grade 12 is the real numbers. It is right below the pi button. So here's pi, there's e, goes second, e. Yeah. You also have to turn your calculator on. Do you know anybody who's in grade 11 taking grade 12 math right now? If you do, ask them if they know what this means, and they'll say yeah. And that's that you'll write that probably 100, 200 times before you graduate in math class. For talking about domain of a function. We're going to get to that. So now, we're going to go back to our initial paper. Doesn't terminate or repeat. What that means is an example like on our sheet that keeps going like this. 8, 9, 10, 11. If I kept going on that pattern, it doesn't end. That pattern could go on forever, repeating itself. You never get the same numbers over and over again. There's a pattern, but there's no repeating of that pattern. There's nowhere that I can put a line over top and say it does this over and over and over again. So that means that it doesn't terminate or repeat. If you type in the square root of 2 into your calculator, you get a decimal that keeps on going, but there's no pattern and it doesn't repeat itself. So that's how you would know that it is an irrational number. So now we go back to our numbers here, and you can choose to either write out the whole word or use the symbol for each number. So 2 is a natural number. It's a whole number. It's an integer. On your, this you write down on your square. It's a rational number and it's a real number. So you can choose to write out the symbols or write out the words in full, whatever you would think would be quicker. $212. That would be all of those again. 34. Is it a natural number? Yes, so it would be all of those again. So I'll give you guys a little bit of a head start and fill the whole page in. All right, let's finish them up. How do you do a 0? For 0, it is a whole number, an integer, a rational number, and a real number. Once you get to -2, when you get to 2/3, 2/3 is just a rational number and a real number. Because these ones are just fractions, they can't be reduced. I gave you guys a head start? Okay, I'll give you guys some more time. All right, here are the next 5. Rational and real, rational and real, rational and real, rational and real, rational and real. They're repeating. All of those can be written as fractions, so they're all rational numbers. Maybe, maybe not. Unless there's any numbers up there that aren't real. Yeah. Yeah, tell me if it works. Okay, next 5. Did you get this was irrational? This one is irrational. The first tricky one, square root of 64 is equal to 8. So this is a natural number, a whole number, an integer, a rational number, and a real number. Yeah. The real should be a big square around the whole thing. So yes, so that's a good, if we go back to our diagram, you can add a big square around the whole thing, that the real numbers are all of them together. Square root of -9. Have you tried, did anyone try that on their calculator? What happened? You got an error when you type in your calculator. This is the only one that is not any number. It doesn't exist.
Oh my goodness.
It's unreal. It's not an irrational number. It's not any number. If you go to your calculator, and you try to type in the square root of -9, you get an error, a non-real answer. Yes. You have to, if you want to go out of real mode, this can exist. If you go to your mode, if you hit the mode button, I have to quit. If you hit the mode button, you will currently be in the real mode. You can also do some unreal math. Okay? Okay. I am now in imaginary mode. No, I'm not kidding. You get 3i. I is an imaginary number. This is true. I'm not making this up. There are some real-life examples which can't be solved with real-life numbers. However, if you solve them with imaginary numbers, eventually the math will go back to real numbers and you can solve problems that were not solvable before. And you have to use imaginary numbers. The imaginary number, I, is right there. It's equal to the square root of -1. Well, you now, for example, there's a joke up on the board over here that before you probably walked by and just went, maybe some of you looked at it and didn't get it. Maybe some of you looked at it and went, ha ha ha, because you thought maybe someone else might think it's funny, so then you laughed, right? You've done that before? So on this joke, you have pi talking to the square root of -1. And pi says to the square root of -1, get real. And square root of -1 responds by saying, be rational. You can actually go online and buy t-shirts with that on it. But only smart people get the joke. The rest of the people just laugh along, right? This is in the video. Square root of -4. Integer and rational and real. Good. Pi. Irrational and real. Is this a repeating decimal? No. There's a pattern that repeats, but the decimal itself doesn't repeat. Same thing with this one. There's a pattern. This one is a terminating decimal, so it is a rational number. And this reduces to 1/3, but that's still a fraction. Are we ready? Okay. So on the next page, you need to label these as either rational or irrational. 3/4. How'd you do? Did you get rational? Root 2. Irrational. This next one. Rational. Pi. Irrational. 4/9. Rational. Square root of 4. Rational. 3.5293. Irrational. And finally, it is repeating. Oh. The dot, dot, dot means that keeps on going, and you look, and yes, it is repeating. Oh, okay.
Do you want to test that?
All right. Next examples. We'll write out natural numbers. Whole numbers is next. Integers. Rational numbers. Irrational numbers. Real numbers. Okay, 44. Which ones? Whole, yes. Natural, yes. Real. Good job. Rational. Done? The thing. Integers. Good. How about -3? Real. Good job. No, it's not a whole number. Integer. Can you write it as a fraction? Yes. How about 0? It's a real, it's whole. Rational. It's not natural. An integer. How about 5/9? Rational. And real.
I
1.35 irrational. It's not repeating. And real. And the last one? Rational. Real. Oops. There we go. Oh, too far. There we go. It's not an integer. Okay, first of all, we are going to estimate these. Of all those numbers without a calculator, which one do you think is easiest to estimate? 7. Square root of 7, what would you say that's approximately? What's it going to be between? What whole numbers?
7 and 0.
The closest to. You're right, it is going to be between 0 and 7. It's going to be between 2 and 3. Do you think it's closer to 2 or closer to 3? 3. So we're going to say 2.6. Okay. Which is the next easiest one to estimate? 19. What do you think that's going to be close to?
9.
No, it won't be close to 9. It's going to be close to 4. Why? Because what do you know? You know the square root of 16 is 4. You know the square root of 25 is 5. Square root of 19 has got to be somewhere between 4 and 5. 4.7. You think it's closer to 5? You think it's closer to 5 or closer to 4?
4.
Okay, so 4.4. 4.4? Okay.
Now 13.
The fourth root of 13. What does a fourth root mean?
I don't know.
It's the fourth of the.
Let's pick it's equal to 2. So fourth root means a number times by itself 4 times. So if it has to equal 2, what is 2 times 2 times 2 times 2?
No, wait. 2 times 2 is 4. 6.
See, square roots is looking for a number times by itself, right? 4 times 4 is 16. A fourth root is saying 4 times you'd multiply that number, and you would get. So what 13 would be between 1 and 2. It's going to be a little bit less than 2. Approximately 1.9. Okay. You're going to do these with your calculator. We'll see how close you are after. Which one do you want to do next? 4th root of 35? Well, 4th root of 2 of 16 is 2. 4th root of what is equal to 3? No, because 3 times 3 times 3 times 3 is not 20.
27.
No, not 27, not 74, not 72. 81. So 35 is between 16 and 81. Do you think it's closer to 2 or closer to 3? 2. Hello?
Excuse me,
Yes?
could Charlie Hinton please be excused?
Yeah, she'll be right down to the office.
Thank you.
So 2.1. Okay.
2.15.
2.15. We'll keep it as 2.1 for now. Which one have we? Cube roots. What cube roots do you know? Cube root of what is equal to 2? Cube root of what is equal to 3?
8.
Cube root of 8 is equal to 2.
And then
27 is equal to 3. So would you agree the cube root of 18 is somewhere between 2 and 3?
Yeah.
What do you think it would be? 2.7?
2.7. 3.
2.7. And the cube root of 38.
3.4.
3.4. So see how close you are by typing those into your calculator. How do you write fourth roots in your calculator? You can push the number 4 to do a fourth root. Then push the math button and go down to number 5 where it has xth root. Push enter to automatically put that little 4 up there for you. Fourth root of 35 is 2.4 until the one that says xth root. There's also a cube root. You just look on the one that, I think it's the 5th one. And then you have your homework at the bottom of that page, so you can do that.